Let's look at a couple of examples in which we're going to explore other ways to algebraically manipulate a function in order to determine its limit as we approach a designated x value. So the first one we're going to look at here is a rational expression with a cubic in it, and we're trying to do the limit as x approaches -3. Now notice the first thing that we would try to do would be to substitute -3 in. However, that yields 0 in the denominator, which is a problem. So that's why we need to algebraically manipulate it. So the way in which we can do that to this one is to factor that sum of 2 cubes in the numerator. Yes, you need to remember how to factor a sum of 2 cubes. So if you take a look at what you have at this point, notice the x plus 3's cancel out. Really what's going to cancel is the part of the problem that was the difficulty that might have caused you to have had 0 in the denominator. So that, it sort of makes sense that the x plus 3's cancel out. Now what you have remaining is what you're going to substitute -3 in. And remember our guideline, so long as we still have our variable in question in the problem, we keep our limit notation. Now that we're going to substitute -3 in place of our x's, we don't need the limit notation anymore. So we have -3 squared minus 3 times -3 plus 9. So this yields us 9 plus 9 plus 9, and our answer then is 27. So let's look at another one. So this will be a slightly different type of manipulation that's required. Notice that if we try to substitute -1 into the denominator, once again we end up with 0. So the type of manipulation that's required on this one is to multiply by the conjugate. Now notice our square root, our radical, is in the numerator. The conjugate of that numerator term is going to be square root of x plus 5 plus 2. I'm sure you learned about conjugates in Algebra 2. And you're going to do that in the numerator and denominator. The idea behind this is essentially you're multiplying by 1 because you're multiplying by something over itself. So that's 1. So you're really not changing the value of anything. You're simply taking what you had and multiplying it by a form of 1. So now we're going to multiply. Remember, we keep our limit notation so long as we have our variables in the problem. Now across the numerator, you really are multiplying of what ends up being a difference of 2 squares. So square root of x plus 5 times square root of x plus 5 gives us x plus 5. The outside and inside terms cancel out. Then we have a -2 times a positive 2, which yields -4. Now in the denominator, I'm not going to actually multiply that out. I'm just going to copy it over, and you're going to see why in a minute. So it looks like that. Please remember you do need these parentheses here, because you are multiplying the one quantity times the other. You also need these here as well, right there. All right, let's go ahead and simplify the numerator, and I think you'll see what happens that caused me to say that I did not want to multiply the denominator out, because notice what's going to cancel out now is the x plus 1's. So your x plus 1's cancel out. Just don't forget you have a 1 up there now in the numerator. So if we substitute in -1, and since we're substituting at this point, we can eliminate our limit notation. So we have a 1 in the numerator. Down in the denominator, we have square root of 1 plus -1. I forgot it was -1 plus 5, -1 plus 5. So that, of course, in the denominator yields square root of 4 plus 2. So that ends up being 1/4 for our final answer. So these were just a couple more examples of other types of algebraic manipulations that you might be required to do as you solve some of these limit problems.